That we will sing the national anthem of Indonesia, Indonesia Raya. I humbly ask all attendees to stand up.
Siapa yang on Zoom? On Zoom, on mic.
Sit down. The next agenda is a speech from the Dean of the Faculty of Agriculture, as well as the official opening of the guest lecture made by Professor Dr. Engineer Anwar Hussein MGM to deliver the address.
Thank you very much. Have you heard my speaking? Is this okay?
Yes, sir.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. And very good morning, ladies and gentlemen, our distinguished guests and guest lecturer. As a keynote speaker today, Bapak Dr. Dominic Akie, as a senior lecturer at the Food Science Department of from University of Otago, New Zealand. Please welcome. Thank you very much, Bapak Dr. Dominic Agie. Honorable Vice Dean of Faculty of Agriculture. Here there is Vice Dean for Academic Affairs, Ibu Profesor Philip Pratama. Head of Agricultural Technology, Prof. Budi Santoso, Coordinator of Study Program of Agricultural Engineering, Dr. Puspita Hati, our beautiful moderator, Ibu Ari Hayati STP MSc. Now she's still in New Zealand.
Here.
Ibu Ari, you're still in New Zealand?
No, I'm here, sir.
Oh, yeah. It's already in our university. Our master ceremony, Muazim Alpas Wicaksono STP, all professor and staff member in Faculty of Agriculture, in particular from Agricultural Technology. Our beloved all students from Faculty of Agriculture, Universitas Sriwijaya, and also from other university, in particular from Department of Agricultural Technology. Dear participants, ladies and gentlemen, first of all, we would like to extend our warmest welcome to Dr. Dominic Akye in UNSRI, even though this lecture conducted through online meeting. Hopefully, one day you should come to our campus and make some activity physically in our university, Dr. Dominic. It is a great honor for us to have you, Dr. Dominic Ake, as a guest lecturer who would like to present guest lecture in the term bio innovation in the polarization of agricultural byproduct to meet sustainable development goal. Distinguished guests, ladies and gentlemen, I think we all agree the term will be presented by Dr. Dominic Ake is a very, very interesting lecture. Discuss about agriculture and byproduct. We know that agriculture and food product is very, very important for our life and also constitute a significant problem worldwide, in particular for the food waste, because of the adverse or disadvantage effect that agricultural waste has on the environment, economic, and society. Many various scientific students focus on the management of food waste studies. A high amount of agricultural food waste and byproduct containing valuable bioactive compound. So minimizing food waste and byproduct is the first option to avoid environmental problem and to help the economic and the society. Today, we know that the bioactive compound in agricultural waste as a valuable resources for the production biofuel, enzyme, vitamin, antioxidant, animal feeds, and various chemical. In case of food loss, the unfavorable effect occurring during food production are increased by food loss in the food system. The total global food loss and waste 1.3 billion ton annually correspond to 1/3 of the food produced to human consumption. It is very, very dangerous for the crisis of food crisis. Bio innovation with nanotechnology and biotechnology approach are recently used as a novel and green application to polarize agricultural byproduct, including food waste. If you want to know more detail about the bio innovation in the valorization in agricultural byproduct, please listen this guest lecture carefully until finish. Don't stop the lecture. Don't go out from this lecture. I think we also hope this guest lecture will strengthen other possibility collaboration with food science department in University of Otago, New Zealand, such as student exchange actually, and then joint supervision for our students doing their final project if it's possible, joint publication, joint international seminar, share equipment lab and library, etc. Ladies and gentlemen, I wish you all an enjoyable time and success during this lecture. Finally, I declare this guest lecture with Dr. Dominic Akye is officially open. May our God always guide and bless all of us. Amin. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Dominic Akye. Come to our campus in Palembang.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Hussein, for the insightful words. Next is the speech from the coordinator of Agricultural Engineering Program Study to Dr. Usfidanati, SMPMP. The time and praise is yours.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Honorable Dean of the Faculty of Agriculture, Professor Dr. Muslim, Master Agriculture, our esteemed speaker, Dr. Dominic Agay, respected Vice Dean Swan, Professor Philip Pratama, the head of the Department of Agricultural Technology, Professor Budi Santoso, or the representative of Department Secretary in Agricultural Technology, Dr. Hilda Agustina, SPP MSc, distinguished professor of the Department of Agricultural Technology, beloved faculty members of the Department of Agricultural Technology, also all lecturer of agriculture, and to all the beloved undergraduate students of agriculture, engineering, agriculture, post-harvest technology, graduate students of agriculture, industrial technology, all students, master, and participants of this international lecture. Allow me to convey a few words as an opening to this event. First and foremost, we express our utmost gratitude to the Dean of the Faculty of Agriculture, Universitas Sriwijaya, for facilitating this event. We also extend our gratitude to Dr. Dominic for graciously agreeing to be speaker for this public lecture. Additionally, I would like to thank the organizing committee comprised of faculty members, staff, and students who have worked tirelessly to make this event possible. May the efforts be blessed by the Almighty. And also thank you million for all participants in offline and online for participating in this event. This event holds significant value for both the students and participants as it provides an opportunity to broaden their global perspective. The topic of utilizing agriculture waste or valorization of agricultural byproduct, which will be discussed, is particularly integrating for both agriculture, engineering, and other agricultural science. It can serve as a source of innovation in agriculture in the future. After this event, we hope it helps students discover ideas and innovations relevant to industrial revolution 4.0, especially in using agriculture waste for their final projects. I think that's all what I could tell you. Thank you for your attention. I apologize for any mistakes. Let's make this event enlightening and beneficial for all of us and our wider community. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Usfidanati. Following the opening remarks, let us take a moment for reflective as we proceed with the prayer. I kindly request Mbak Novia to lead us in a prayer.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Anda syakir, anda nami, anda yuafi amma kuwika inna ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa ala sultan subhanaka la nuhsi sana'an 'alaika kama asnaita 'ala ala sayyidina لنا جل الحاجات وتغفر لنا بها من جميع السيئات وترفعنا بها تعالى درجات قلبك بها الصالحات اللهم نعوذ بك من لا ينفع ومن قلب لا يخشع ومن نفس لا تسمع ومن دعوات لا يستجاب لها اللهم نعوذ بك من ونعوذ بك من العجز والكسل ونعوذ بك من ونعوذ بك من الخلق في الدين ربنا تقبل منا انك انت السميع العليم وتب علينا يا مولانا انك انت التواب الرحيم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه والحمد لله رب العالمين. يا رب العالمين. السلام عليكم ورحمة الله وبركاته.
Thank you, Patty. Moving on to the main event today, which is the presentation from our guest lecturer, Dr. Dominic Age, Senior Lecturer of the Food Science Department of the University of Otago, which will be moderated by Mrs. Arihayati, SPPMSC. Please welcome Dr. Dominic Age and Mrs. Arihayati.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. Welcome to our international guest lecture. I'm Adi Hayati, and it's such an honor to be your moderator for today's event. I would like to extend our sincere appreciation to our team, Professor Musli, Vice Dean Professor Tiri, and also for our Secretary Department, Ibu Hilda, and other colleagues, lecturers in Agriculture Engineering Study Program, and also for everyone who joined us here. Before we get started, let me take a moment to introduce our esteemed speaker. And before that, I want to say hi first to Dominic. Hello, Dominic. How are you? Can you hear my voice? Is it clear in Zoom? Is it clear in Zoom?
Yeah, it's okay. I can hear it.
Okay. Yeah. So allow me to introduce Dr. Dominic Age. Dr. Dominic Age is a senior lecturer at the Food Science Department of the University of Otago, New Zealand. He holds a BSc degree in Food Science and Technology from NAS Ghana and a PhD in Chemical Engineering from Monash University. Following his PhD, Dominic served as an Alfred Viking postdoctoral research fellow at Deakin University, focusing on the chemoenzymatic techniques for developing peptide-rigid bioconjugates for food and pharmaceutical application. Dr. Age's research applies in silico tools and bioprocess engineering principles to convert biological materials into high-value bioactive products. He also explores the nutritional and health benefits of edible insects, an emerging area of study. His contribution to food science were prestigious 2021 International Union of Food Science and Technology, or IFOS, with Young Researcher Award. He actively serves on the Administrative Council of Early Career Scientists of IFOS and is a recognized doctoral supervisor according to the UK Council for Graduate Education's Good Supervisory Practice Manual. And I'm lucky because I'm one of his students. Now, let's move on to the heart of today's discussion. Dr. Age will be sharing insight on bioinnovation in the valorization of agricultural byproducts to meet sustainable development goals. In his lecture, Dr. Age will discuss the role of agriculture and food science in meeting sustainable development goals at addressing the problem of food waste and the opportunities in utilizing agricultural byproducts to generate
help promoting ingredients. With his experience and expertise in this field, he's the perfect person to lead us through today's discussion. Following Dr. Agne's lecture, we will have a question and answer session. So please feel free to prepare your question or any thoughts or any comments. So without further ado, please, Dr. Agne, the times and screens are yours.
Okay, yeah, thank you very much, Ari, for the warm introduction. It's really good to see you again. Now, can I check if you can all hear me clearly?
Yes, sir.
Oh, okay.
Yes, that's okay.
Okay, that's good.
Hello? Yeah.
Okay. Yeah, so I'll first would like to also show my appreciation and thanks to your Dean, Professor Muslim, for giving me the opportunity to give this talk, and also all of the staff members who've worked behind the scenes to put this program together. And also to you, Ari, for giving me having a chat with me before you left about the possibility of giving this talk. So I'll quickly move on and share my screen. So now just one last final check. Do you see my slides?
Yes.
Yes. Okay, that's really good. I have about 3 different computer screens in my office, so I have to make sure I'm looking at the correct one, which is this one. So today I will be talking about the topic as has been introduced on bioinnovations for the valorization of agricultural byproducts to meet SDGs. And I'll quickly run through this outline. I'll make a case why agriculture is really important, especially in our times, looking at all the things happening globally in terms of population growth and the need to feed people. And I'll make a case why food is sitting in between agriculture and nutrition, and why food science is really important as a discipline that needs to work together with agriculture to be able to meet all these different goals we're talking about. And then I'll highlight some of the global challenges in feeding populations and some tools we have for valorization of food waste. And on that note, I'll mention some of the work we've done here in our research group, and then still talk about some challenges that are still remaining and opportunities for collaboration and multidisciplinary solutions, as was highlighted early on by the Dean. And then, as Ari also talked about, I'll give ample time for question and answers. I would say especially for students. I always like to talk to students, so hopefully there'll be some questions at the end from you, which I'll try and respond to. So we'll begin with the Sustainable Development Goals. I'm sure you are familiar with these, especially the students, the 17 goals that proposed by the UN. And I believe, and I feel you agree with me that to solve any of these challenges, get my pointer, to solve any of these challenges, we need to begin with agriculture. Okay. Yeah, to solve any of these challenges, we need to begin first with agriculture. It's almost like you can't do anything on an empty stomach, to put it simply. And one other interesting thing is agriculture, as we know it, actually touches on almost all the 17 SDGs. So whether you're talking about number 1, which is no poverty, agriculture touches on it because agriculture employs a lot of people. If you're talking about preventing hunger, obviously agriculture is how we prevent people from going hungry. And number 3, about health, agriculture is leads to the production of food, and then food is important for health. In some parts of the world, agriculture is closely linked to quality education, gender equality, so many things. So agriculture is really important if we are to address these SDGs. Now we are in 2024. And I think these SDGs were set up between 2015 and the review will happen in 2030. So it's almost just basically 6 years away from having another look at the SDGs to see how far we've progressed as a planet, globally. But it's really important to get an understanding clear that agriculture is really crucial to achieving all these goals. So for an institution, especially like yours, that focus on agriculture I would say to the students, you are in the right profession, especially because you can link what you are studying to the big global, goals that we want to solve as humans. So that's the first thought. Now, I had a look at your website and I saw this quote from Professor Muslim, and I really like it because it's talking about, he actually used the same word I have in my title, the word innovation or innovative. So he says, let's synergize together to produce great innovative works to solve agricultural and other problems through the 3 pillars of higher education, like education and teaching, research and development, and also community service, which is basically the same 3 ways in which universities, even here in New Zealand, how we assess our contribution to the community. We look at how well we are doing with teaching, how well we are doing with research, and also community service. So it looks like using those 3 framework is really an important way to look at how much impact or how much progress is being made in this whole enterprise. And another way you can also measure success, again, in TRACE, is look at what we call the triple bottom line. This phrase is actually used in the business world where they measure a business success in 3 areas: the profit, how important it is to people, and also the planet. And I've put this diagram here just to capture that. Now, from our perspective, especially as agriculturists or food scientists or even nutrition, we are looking more on the area of health of people. And then there's also the profits, economics, and then the planet. And then immediately you can see, as I was explaining in the previous slides, that agriculture has something to do with these 3 things. Because agriculture is important for people, for profits, and also has some health implications. So let's look at some of these. First one, if you look at the first category with people, you can understand that all food comes from the agriculture sector. Food as we know, it comes from agriculture, so it's really important. And also nutrition is indispensable for health. You cannot have health without nutrition. There's a sense in which there are only 2 products that humans consume on a regular basis. There's food and medicine. Medicine is something we only take when we are sick, okay? But food, we need it regularly. So that makes agriculture really, really important for people and also for people's health. And we also know that diets contribute to a lot of diseases, especially if you indulge in bad dietary habits. So again, there too, we get a clear link between agriculture and its role that it plays in the health of people. We can also look at the profit side. So this is where we throw in a few things around economics even. And agriculture is the world's largest employer or the world's largest industry. So agriculture employs more people in the world than any other industry, which again tells you how important it is. And also, agriculture is one of the areas which is more, you can say it's more pro-poor. Now, what I mean by that is, if you want to come up with any intervention to help, let's say, poor people in a particular community or in a country, and there are poor people in almost every country in the world, if you want a strategy or an innovative way or an intervention that can actually help people who are poor, agriculture is actually one of the areas to look into. Okay, which makes it really important, again, from the economics perspective and for the profits angle. Then we also know that agriculture has some impact on the planet because agriculture uses about 38% of all the global land surface. That's almost 40%, which is really significant portion of the Earth's surface that is used to produce food. And by implication, it also means you can understand why agriculture will have a huge environmental impact, because if you're using that much land surface, you obviously will know that it will have some impact on the environment, which is why we promote, positive agricultural practices rather than negative ones. So I have it here that it's impossible to improve the nutrition and health of people without agriculture. And obviously, there's also some economic implications and also planetary implications there. Now, if we pick the people and health, now this is where I'll start focusing on the food aspect, okay? If you pick on people and health, the thing to think about is that you can almost say that the primary goal of agriculture is to ensure food security. Now, I like this definition from the UN Committee on World Food Security, and they defined food security as the state where all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food that meets their food preferences and dietary needs for an active and healthy life. You can see that this definition is really elaborate and very comprehensive. So I've split it down here. The main things, you can almost say the pillars that food security rests on is, the first one is accessibility. And that is the fact that people should have access to the food. Now, the access can come in two forms. There's physical access, which is where you can think of it that you need to be able to walk into, let's say, a shop or a supermarket or a store to buy the food. You need a physical access to the food. But there's also economic access. That is, you need to be able to afford it. If you get there, the price shouldn't be too much that you cannot afford it. So the two need to go hand in hand to be able to ensure food security. There needs to be accessibility to the food. The other one is that the food needs to be acceptable to the person consuming it. So acceptable, this is social acceptability, religious acceptability, and also personal preferences. If somebody avoids a certain food for cultural reasons or religious reasons, there should be alternatives for them to be able to, access and consume for their everyday life. So acceptability is also really important. The third one is sufficiency. That's to say the food needs to be sufficient for everyone. There needs to be enough for each person, not just a bare minimum. And then it needs to be safe. Obviously, we are talking about food here. We want something that is safe, not toxic. So the food should not cause any injury or ill health to the person consuming it. And then by implication, it also needs to be nutritious because, again, we are talking about food. And one of the reasons why we consume food is to get nutrition. Nutrition that is important for the body's, meeting the body's physiological needs. And then lastly, it also needs to contribute to health positively. But I make a case that even though, now I started by saying that the primary goal of agriculture is to ensure food security. Now, secondary goals could be, and then there's economic implications and all of that. But the primary goal is to make sure that food is available, it's accessible, it's acceptable, sufficient, safe, nutritious, and also healthy. But I think agriculture alone cannot assure food security. We also need food science. And that is because the typical agricultural produce, now, for the most part, we don't consume the food in that state when it's ripe, directly comes from the farm. For example, if you harvest rice, now I grew up, my parents have, by the way, I should have given a quick introduction. I'm from Ghana in West Africa. That's one reason why I included the photo of cocoa in the slides, because we make the best cocoa in the world, I think, for chocolate. And my family has cocoa farms. We have rice farms and all of that. And when you harvest the rice or the cocoa, that is not what you eat. It needs to be processed into some form. If you harvest some fish or you have a piece of meat, it needs to be processed into a form that is, appetizing and also safe for people to consume. So I look at food science as the bridge between agriculture and the consumer, or between the farmer and the consumer. Because the produce, again, in this raw form, usually that's not how we consume, except maybe a few fruits and vegetables where you can consume right at the farm gate. So we need to be able to process and formulate this to to make sure that the food, the final food that is set on the plate and put in front of someone is accessible and acceptable and sufficient and safe, and all the other pillars of food security that we looked at in the previous slides. So agriculture is really important, but to feed people, we need to add food science to it. But then there are a lot of challenges that we face globally. Okay, so of course there's the challenge of achieving the SDGs. There's also the challenge of fighting hunger and malnutrition around the world. Now I'll come to that in a moment, expand it a bit to look at some other aspect of that problem. But the third one down here is, you may have heard, people say that the world's population is going to go to about 9 billion by 2050. That's just roughly 25 years time, which is not a lot of time. But even though human population is increasing by 35%, the amount of food that we need should be doubled. The challenge here is, how do you double food production when we still have one planet? It's not like there's a second Earth that some of us can move on to meet our food needs. So this is where the thing about, that's why it's a big global challenge. How do we feed a growing population? Another aspect of the thing, the challenge is that the average consumer nowadays is concerned about sustainability. Now, the word sustainability can mean different things to different people. The way I understand it, or I explain it, is that it's just the English word sustain. So can we keep doing things in the same way? Is this sustainable? So that's really the point here. And the question now is, can we, if we want to feed the world, we need to do it sustainably so that we can keep doing it, as it were, forever, indefinitely. But the average consumer nowadays is, there's so many different things that people want. People want to know what is in their food, where the food comes from, or traceability, what's the carbon footprint or environmental impact. Some people perhaps will only consume food if it's organic. They want food that is free from something, maybe free from soy, or free from GM product, or free from gluten, or anything really. They want to know whether the food is sustainable, and whether it's healthy, and whether it's nutritious. And sometimes some of these requirements counteract each other. As I'll explain that just in a moment, so you understand what I mean by that. All of these make feeding people nowadays a big challenge. Okay. Now, I've picked some of the SDGs, number 2, 3, 12, and 13, because here this is where we see clearly how agriculture and food science come together, to make sure that there's no hunger and improve people's health, and also to assure responsible consumption. Now, SDG 12 is where we have the problem of food waste and also climate action. So let's see this in a bit detail. So goals number 2 and 3, the reason why I bring them up here is because I started by talking about how we cannot solve any of the SDGs without agriculture, because agriculture is important for feeding people. Then I also said, but we need food science, because when the agriculture or the farmer produce the food, we need somebody with the science to process this into a form that is safe, for human consumption, and also palatable and tasty. But there's also undesired consequences, and this is where bad nutrition comes in. The word malnutrition, sometimes I from my experience, students get the impression that whenever we hear the word malnutrition, we only think about people who are starving, but it actually also works on the other side of the scale. So overweight and obesity is a form of malnutrition, as is undernutrition. Undernutrition is where you are not having enough nutrient to meet growth and development. But if you also have too much of a particular nutrient, it's also a problem. So both sides are a problem. And it's such a problem that, this statistics, I think it's from the WHO, that more than 1 in 3 low income and middle income countries are affected by both undernutrition and obesity. They call that the double burden of malnutrition. This is where in a particular country or particular household, you can have people who are obese and also undernourished at the same time. It's a really big problem for the health sector of that country to deal with. Now, if you come down here to the slide, this is just an example to show you that the double burden can be at a country level or household level, or even at the individual level. Like you can have somebody who is deficient in macronutrients like minerals, but is also obese, okay? And this is just to show you how important proper nutrition and diet is for health. Again, this is also some other statistics from WHO. Why do we need to worry about all these things? Why do we need to act? Because addressing malnutrition is important to achieving the SDGs. Remember, SDG number 3 is talking about good health. And also, nutrition is important for health and economic development. If people are unwell, they will not be able to work. And if they don't work, it means typically they will stay in the cycle of low socioeconomic status or even poverty. But once you have good nutrition, it's good for mothers especially, because they will pass on good nutrition into the children. There's a whole field called nutrigenomics, which is coming up nowadays, that says sometimes even the nutrition that your mom had when you were in the womb can affect your chances of being exposed or predisposed to diabetes. Even before you are born, before you start eating anything at all, it's like it's already programmed when you were 9 months in mom's womb. That making nutrition a really important area for us to look at. Of course, good nutrition is also good for children, performance in school. Not just children, I think young people in general, students as well. It's also important for building good immunity and reducing the risk of diseases. So all of these things are really crucial things that we have to look into. The other side of the whole thing, if you put health aside and look at the problem of waste, okay? Here are some statistics just to show you how much food is wasted globally. Now, this data is probably a little bit old, but the results are still current in the sense that so now a lot of food that is produced, do not end up on the plate. So for cereals, it can be as high as 30%. Fruit and vegetables, almost 45%, because those ones are quite perishable, including root and tubers as well. Oil, seeds, and pulses, 20%, meat, 20, 30 for fish, and then 20 for dairy. That's a lot of food that goes to waste, and doesn't get consumed, which is a problem. It's a problem because we lose money, or it has economic implications, but also it's a problem because once these food end up in the landfill, they emit greenhouse gases, which contribute to the total amount we have in the atmosphere, which has environmental consequences there too. So the point is something needs to be done. But the thing that needs to be done can become a bit complicated because going back to the definition of food security, sometimes, remember I made a comment and said sometimes the requirement for one can start to be opposed to another requirement. Now, this is what I mean. Sometimes if you want to make sure you produce sufficient food, so you want there to be a lot of food available so that there's always food, let's say in the supermarket, for example, it might mean that you only focus on a selection of foods at the risk of others, because to be able to produce enough, you have to pick foods that maybe we have the technology for growing on a large scale. And that often means you'll probably not get as much diversity because you focus on yield, a wide bounty harvest, rather than having different kinds of food. This is one reason why, for the most part, in many countries in the world, indigenous food seems to be, it looks like we are losing the technology and the knowledge about the foods that our ancestors consumed, because more and more agricultural practices sometimes prioritize the food that we can grow on a large scale to the neglect of the ones that may require a lot of work just to get a small amount of harvest. So in trying to make sure there's sufficient food, it can come at the risk of getting a diverse kinds of food. And also, second one here, when we want to make sure that the food is safe, for consumption and also accessible. It means we have to process it. It's like there's no other way to do it. Before the food can be put in the supermarket for us to be able to go and buy it, we need to process it in a way, put it in a package so it's protected and doesn't, we don't get food waste again. But we also know that processing has some unintended consequences on the nutrition and the healthiness of the food. So there too, you begin to see that to get safety and accessibility, we have to compromise a little bit on the nutrition. Other than that, you cannot get both. And again, this is another one here, acceptability and accessibility. For the food to be acceptable to certain people, sometimes it means it may no longer be economically accessible, because to produce food that is free from something, maybe here in New Zealand, lactose-free milk. So to buy milk that is free from lactose for people who are lactose intolerant is slightly more expensive than the ordinary milk, which has lactose. But to produce lactose-free milk is good because it means you are ensuring acceptability for people who are lactose intolerant. But that also means you are reducing the economic accessibility, because now the milk becomes slightly more expensive and some people may not have the economic means to afford it. So again, the challenges we face are really complex if you look at it from that perspective. And bottom line is also that with food, always there's some level of waste that is inevitable, because it's not everything in the plant or everything in an animal that we consume. Some things you can't possibly consume. Let's say chicken, you can't possibly consume the feathers, that will end up in waste. But we can do something about it. And this is where I think the word valorization comes into place. So the question is, can we think of a really clever, innovative way to make sure that we always have a win-win solution, even if a compromise is needed? And I think this is where adding value to byproduct or waste come in. Now, I did a really quick search in the literature, something we call bibliometric analysis. And this is it's a type of statistical analysis that you do to assess the kinds of research that is being published on a topic. So I did a quick one where I looked at the phrases food waste and their valorization. I searched for these on the Scopus database and just look at just three main things. There's a lot more we could do, but just to make sure that the talk is not too long, I looked at publication output, keyword categorization, and also some hotspots areas of research. Now, this graph shows the result I got. So basically, if you just search for the phrase food waste and valorization, you get this output. The blue line is to tell you how many papers are published per year up until, this is until 2023, yes. 2024, the values will change, so I didn't include it, because we are not at the end of the year yet. But if you put everything together cumulatively, there's over 1,400 articles so far, just on the Scopus database, okay? But the point you can see is that the whole field of food waste and valorization, especially, is quite new. You can see as of 1980, like one paper was published and nothing happened until after 2000. And even after 2000, only a few papers were published. It's just before 2015 that things began to pick up, as it were, exponentially. And that sometimes gives you an idea whether the field is a well-researched area or it's new. And I think it's new. And I think it's quite linked nicely with the 2015 SDGs. When the SDGs began to be made popular, people realized that to be able to meet the needs of people, we have to look back at what we call waste or byproducts and maybe get some more value out of it. Another thing is among all those over 1,400 papers, about 60% of them are original articles. So experiment that people do, and then just over 20% are review papers, and 12% book chapters, and then conference papers and the rest. The fact that we have a significant big articles tells you that the field is also highly researched. People are not just writing reviews and recycling information, but quite a lot of original studies are also happening in the space, which is good. If I look at the subject area, so now the question is, of all the publications on food waste and valorization, what are the subject areas that people are publishing in? you can see that the biggest one is actually environmental science, which means people look at this problem primarily because of its impact on the environment, at least so far. These statistics can change based on, now if I do the same bibliometric analysis at the end of this year, I may get slightly different results because it all depends on the kinds of publications people put out. And then there's also a link to energy. And when Professor Muslim was talking, he actually made mention of the fact that food waste are being converted into biogas and biodiesel and all of that. Now that fits nicely into this here. There's also some emphasis on chemical engineering. And I know some of you are studying engineering, so you appreciate why that is the case. And obviously there's food waste is, it's in the agriculture and biological science field. Engineering is also there, but these are the top 5, you can say: environment, energy, agriculture, and then engineering. And then you have the rest: biochemistry, chemistry, even social sciences is there, a bit of medicine, computer science, and the rest. The bottom line is that the whole subject area is very multidisciplinary, which makes it good. It means to solve the problem of food waste, we don't just need to know the engineering side of how to convert the material into a useful product, but sometimes we need a social science aspect. Will people buy the product we are trying to make from the waste? It's a really important question to answer, because sometimes scientists, we can get very excited about our technology and then go to the lab and make this amazing product, and then we give it to the consumer and they say, no, I don't want it. And sometimes we may need to work backwards to say, here's a problem. This is a potential solution that we have. Would you be interested? And then the consumer might say, yeah, I'll be interested if you do it this way. Then we go to the lab and try and do something about it. So some of these bibliometry analysis can give quite good insight into some of the ways to tackle the problems we are looking at. Okay, the last one on the bibliometric analysis, then I'll move on to some of the research we have done. As this is a keyword analysis, keyword cluster analysis. So when people publish, you're familiar with the fact that you have to write keywords, and those keywords are the things that can be used to search for your paper on the database. If you put all the keywords together, let me see whether I can zoom in a bit just to make it bigger. No, it's okay. If you put the keywords together, you get all these different keywords here. So obviously food waste is the biggest one. Valorization is another one. But you begin to see that there are some studies that are looking at like food waste valorization and how we get byproduct, bioactive compounds, phenolic compounds, polyphenols, all the red colored ones. That immediately gives you an idea to say, oh, actually people are looking into how we can convert waste into bioactive materials that are important for health, okay? If you come into this blue one, you can see waste management, chemicals, levulinic acid, food waste recycling. That also gives you an idea. This is just how we manage waste, okay? We can look at this yellow one, the cluster, anaerobic digestion. Then you know, okay, biohydrogen, biomethane, composting, methane. That tells you this is all the renewable energy category. So even doing this network analysis alone gives you some information on what are the things people are doing with waste, okay, and how effective have they been, which is also really good, an important thing to keep in mind. So when I did mine, basically these are the conclusions I drew. I saw that generally there are studies that are looking at converting waste. I need my pointer again. Yep, converting waste to value. And they do that using either extraction technology. So this is where they try and extract something of value from the waste, usually with the help of some sort of energy, microwave, ultrasound, or hydrothermal liquefaction. So, this is where you heat something in the presence of water. There were also a category of studies that were looking at converting waste into energy, like I mentioned earlier on. This is where anaerobic digestion comes in, biofuels, biohydrogen. And then there's also other category of studies that are basically looking at bioconversion systems. So how are enzymes being used? How are microorganisms being used? And even insects, because in some of the studies, they use the waste to feed insects, and then the insects now become either food or feed, especially if converting it into fuel or energy is just too expensive, or trying to extract something of value from it is just not worth it, because you spend too much energy to extract something, the yield is so little that if you put it on the shelf, it will be too expensive for people to afford it. And the best method would then be maybe just feed it to insects, let insects use it up, and then they will put up, insects are rich in fats and proteins and all of that, some of which are consumed. I do some work in edible insects, which I'm happy to talk about maybe another time. But for the most part, insects can be used in aquaculture feeds or in feeding chicken and so on. So you can use the insect as feed, which then becomes food in the end. Okay, so now I'll look into some of the work we have done. Quite a broad category. Now, some of these things, since I was doing my postdoc, like bioprocessing of polyphenol-rich ingredients from olive pomace. I did my postdoc in Australia, and there was a company that produced olive oil. You know that when you get the olive fruit, they take the seed, crush the oil, you end up with the pomace, which is very rich in polyphenols. And because it's very rich in polyphenols, it's not a good idea to just dump it into the environment, because it has a really high BOD and COD, biological oxygen demand and chemical oxygen demand. The best way is to get polyphenolic compounds out of them. So we did some work on that, even published a book chapter on it. Currently, I have an MSc student looking at mushroom byproducts, where we are extracting the sterols from the mushroom. Actually, not extracting it, but we are treating the mushroom byproduct so that we can get sterols, and especially vitamin D2, because you can't make vitamin D. Just like they say, vitamin D is called a sunshine vitamin, because when it hits the skin has the ability to convert some sterols into vitamin D. The same thing happens in mushrooms. So we are using that technology to viralize, the byproducts and get sterols out of it. Then we've done some work on whey virialization. So this is whey from dairy proteins, and also detoxifying flaxseed meal, as well as getting bioactive compounds from protein. So I'll talk about the ones I've highlighted in blue in a bit detail. Now, as I go through it, I'll just show an image of the papers we have. Now, if you are interested at all, please get in touch. You can talk to Ari. She'll give you my email. Get in touch. If you want any of the papers, I can send them to you just to read a bit more. Okay, so let's start with whey valorization. We do know that milk contains proteins, and the proteins can either be casein or whey. And usually after you make things like yogurt, especially Greek yogurt, you may know that Greek yogurt has slightly higher protein content than average yogurt, because they concentrate the proteins after it curdles to get more in the tub. And also some types of cheeses, once you make the cheese and you remove the casein, coagulated casein, you end up with this thing here, which is whey, high in lactose, high in whey proteins, and also high in minerals. Again, it is so nutritionally rich that you can't just dump it into the environment. But we can convert it into something, again, because it contains lactose, proteins, and minerals. But then the question then becomes, what do you do with it? But sometimes one strategy, if you are thinking about valorization, is you just have to know what is in there. The composition can give you an idea of what you can get out of it. Okay, so if something contains protein, then it means, okay, if you want to get value out of it, it needs to be something that can be derived from protein, or it needs to be something that can be derived from lactose. In my case, I had to come up with a way to use whey, and I wanted to make something out of both the protein and the lactose at the same time. So I had to think about a strategy. And my strategy was to use fermentation, because fermentation is a really technology which you can do fermentation in any part of the world. In fact, in the part of the world which is warmer, like in Africa, and I would say even in Asia, including Indonesia, fermentation is perfect, because you don't have to add energy. You don't have to heat things before they ferment. You can almost leave them alone and they do their thing, create the products of choice. So I had to select fermentation. That was the first thing. The second thing was, okay, if I select fermentation, what particular microorganism am I going to use? And I decided to go with this organism here. It's a lactobacillus, simply because lactobacillus are lactic acid bacteria, such as the ones used in yogurt. They are food grade, so there's not going to be any problem if later in the end you want to make a product for food, human consumption. But because my PhD was in chemical bioprocess engineering, I had to think about, put my engineering hat on and think about all these different things, the cost, the safety, the scalability, and also the sustainability. As engineers, we always think about that. We don't just make a product. You want to make it at a low cost as possible, in a way which is safe, in a way which can be scaled up, and also, again, sustainable. We can keep doing it indefinitely. But I chose these two enzymes because both enzymes are produced by lactic acid bacteria. The first one is beta-galactosidase, which is the same enzyme that is in our bodies that digest lactose. People who are lactose intolerant, they lose that enzyme a bit when they grow, right? It's the same enzyme called lactase. What it does, it's used in products to make lactose-free milk, for example, or to increase the sweetness in milk, or to prevent lactose crystallization. You just add it to milk and then it will break down the lactose so that you don't get any crystallization. But importantly, you can actually use it to prepare galacto-oligosaccharides, which is a prebiotic, something good for gut health, which makes it a really important enzyme. The other enzyme I looked at is cell envelope proteinases. And as you can see from the name, you get an idea that this is an enzyme that breaks down proteins, the proteins to peptides. This enzyme is important for the microorganism to be able to grow in milk, because even the microbe needs the enzyme to break down the proteins in the milk so that the proteins can now become amino acid, which can be absorbed by the microorganism. But as it breaks down the proteins into peptides, some of these peptides have bioactive properties. So they act like drugs, which is, again, something of importance to us. So first, I decided on fermentation, then I had to choose an organism and think through safety, cost, sustainability, and all of that. But obviously, the first step is we need to produce the enzyme. And to produce enzyme from microorganisms, you want to look at how best to feed the microorganisms so they give you what you want. So you look at the carbon source, carbon-nitrogen ratio, optimum temperature for growing, optimum pH. You just pamper the microorganisms so they give you what you want, basically. Look at how much oxygen is needed, whether you need to stay or not, how much inoculum to start with. So I did all of that work. And again, I'm happy to share the different papers we published. And after we produced the enzyme, we had to purify or immobilize the enzyme. So that way we can reduce the cost, because once you purify and especially immobilize the enzyme, you can use it more than once. So the overall cost becomes cheaper. So, but to do that, we needed to first know the location of the enzyme. Is it intracellular or extracellular? And what is the best way to extract the enzyme? After extracting, we have to purify with ammonium sulfate and chromatography, and even looked at immobilizing the enzyme. One clever way we did it was to immobilize the enzyme on polyester, the normal polyester fabric, because that way we could pack the polyester in a column, so that if you run your way through the column from the top, the reaction will happen as the thing passes through the column, and then coming out from the end, you get your oligosaccharides and peptides. So there too, we published some papers, which again, I'm happy to share if you are interested. Okay, we have to test the enzyme, of course. We need to make sure that it's working. So here, a few biochemistry, comes in, things like Km, Vmax, storage stability, optimum temperature and pH for the enzyme, and how the enzyme becomes thermally inactivated. You can see there as well. And then lastly, we apply it, test to see whether it's working. So we're able to come up with a scalable bioprocess for making these peptides, as well as making oligosaccharides. Okay, so bottom line, we had lactose to start with, and by looking at using an enzyme process, fermentation, we now have a high-value functional ingredient, which consists of both bioactive peptides and oligosaccharides, really important for health. So something which otherwise would have gone to waste now becomes something that is useful. So that's the first example. Second example is flaxseed meal. Again, you know about flaxseed. It's considered as a superfood, typically has about 40% oil and then 60% meal. Once you extract the oil, you get this meal, which is high in proteins, high in fiber, and also high in lignin. So it's a very important, superfood, even you can call it. In New Zealand, the value, the market value seems to be growing. Now, if you look at whole flaxseed, it's about 8 grams per kilo, and the oil is quite expensive, $43 per kilo, because it contains omega-6 oils. But the meal that is left behind, which I said, very high in proteins, fiber, and lignin, you would think it would be very expensive, but it's very cheap. It's just $2 per kilo. And it's now actually used as an animal feed. And for the simple reason that it contains some compounds which makes it toxic. These are cyanogenic glycosides. Some of you may be familiar with it. Things like cassava, some cassava, especially the beta varieties, contain cyanogenic glycoside. Some bamboo shoots contain cyanogenic glycoside, and so is flaxseed. And in many parts of the world, they do not want people to import flaxseed meal until the levels of the cyanide is degraded down to 10 parts per million. In New Zealand, it can be as high as 360 to 390 parts per million, which is a lot. And when you extract the oil, it actually concentrates how much cyanogenic glycoside you have in there, because these glycosides are water soluble. So when you remove the oil, they stay in the meal, which poses a big problem. So we have to find a way to deal with it. And we work with a company here in New Zealand to come up with a process where we are able to degrade the levels from about over 400 down to 37, which is a really significant achievement. And the method just relied on using some type of enzymatic processes where we cut off the cyanide from the sugar. Remember, it's a glycoside. So that now that the cyanide is free, we can extract it out, because cyanide, hydrocyanic acid, is actually volatile under room temperature. So the detoxified meal can now be used at a level where we are making the most out of the proteins. And in fact, the proteins can now even be a source of bioactive peptides, which is the next thing I'll talk about. Because we do know that proteins are made up of amino acids. We join together to make peptides. We join together to make the proteins. So if we know the sequence, we can almost predict the kind of bioactive property we are dealing with. And this is where something we call structure-activity relationship modeling comes into place. Now, I'll show you some examples just briefly, especially for the interest of the students among you. Again, you can get in touch or download these papers for a bit more detail. Now, the point here is, if you want to make peptides from these flaxseed meal, you have two options. One is get the proteins, extract it out, and try as many enzymes as possible. It's going to take a lot of time, very, very expensive, but you can do it differently, which is take the protein and then go online to a database which has been populated with the protein sequences of flaxseed, okay? But once you are there, you can get the protein sequences, everything electronically, do an in silico or electronic digestion, select as many enzymes and try them, and then check so many different things, what bioactive peptide you will get, whether it will be allergenic or toxic, whether it will be medicinally, chemistry friendly, and so on. Just check all of that on a computer before you go to the lab. It's almost like you do modeling before you go and do the wet chemistry. So we tried that on flaxseed meal, and this is one paper. I think we have 2 or 3 papers on it, but just showing one today. So we did in silico hydrolysis using this database, where it allows us to select different proteins and enzyme combination. But our focus in this case was to look for peptides that have hypotensive behavior, or peptides that can control hypertension. And then we check how well they will be able to do work in the body as though they are drugs. So we check things like absorption, digestion, metabolism, and excretion profile, and then did a bit of molecular docking of those peptides to the enzymes to see how well they will bind. So let me show you the result. when we did a screening with microbial enzymes, plant enzymes, and gastrointestinal enzymes, you can see clearly that the plant enzymes are the best option. Remember, everything I'm showing is just in silico. Again, to cut down costs, we had to do it that way. You can see that the plant enzymes were better because they were producing a lot more different kinds of peptides, especially the ACE inhibiting peptides, and also even renin inhibiting peptides. I didn't go into detail about the biochemistry of ACE and renin, but again, for the students, just remember those are two enzymes that are involved in how the body controls hypertension, okay? So you don't want the activity to be too much, because that way they constrict your blood vessels too much, which means your heart has to pump harder. And if your heart tries to pump harder, you get high blood pressure. So you want something that will inhibit those enzymes, so they just chill a bit, ease up a bit, and then allow blood to flow normally. So we found out that using plant enzyme is the best option. If we hadn't used that in silico too, it would have meant going and buying all these enzymes and trying them in the lab, which to some extent would take a lot of time, also be very expensive. And then from the list of many, many hundreds of peptides, actually thousands, you could see we got over 2,000 ACE inhibiting peptides and about 200, over 260 renin inhibiting peptides. 7 of them were quite unique. These peptides had the ability to both inhibit ACE as well as renin. So we selected those ones of interest. And I've shown them here in their bioavailability radar plot. Again, I will not go into too much detail, but the point is, if you have a compound and you plot it based on things like lipophilicity, molecular size, polarity, insolubility, and all of that, and it fits in the shaded region, it means that compound could potentially act like a drug, which makes it really, really important and useful. So we tried that for the peptides and even compared it to standard drugs that are currently used on the market. Captopril is an ACE inhibitor, and this one, aliskiren, is a renin inhibitor. But you can see that our peptides were performing as well, at least based on the bioavailability radar, as some of these standard drugs, which make them really interesting and important. We also did molecular docking, where we check how the peptides will inhibit the enzyme, and then calculated the binding affinity and then inhibition activity. So the point is, the lower the value, the lower the Ki value, the better. So as you can see here, captopril had a value of about 20, and all our peptides even had values lower than that, except this one, LR. Some like KF was very low, 4.4 and 6.1, which means potentially these peptides will possibly even be better than the drug as we know it. And some of these drugs actually have side effects like itchiness and so on, but the peptides, we don't anticipate any side effect because they are coming from a protein, which is a food grade source. And the same thing for the renin as well. So here you get the point that by combining a series of enzymatic hydrolysis as well as even in silico modeling, we are able to enhance the value of flaxseed as we know it. But now I'm getting close to the end. But with all that I've said, we have to also keep in mind that there are no easy solutions, because recently, one of our colleagues in our department, this is Professor Uwi, who's actually from Indonesia. I'm sure most of you know her, and she's the I'm the co-supervisor. She and I supervise Ari's PhD. So they published this work on biodegradable plastics. Okay, now people will say if something is biodegradable, it's good for the environment because, again, once you throw it out, it's going to degrade. But they found out that biodegradable plastics can still pollute water bodies because some fishes, when they consume the biodegradable plastic, it's actually not good for them. So you can begin to see that even though biodegradation as a whole field is important, we also have to keep in mind that it's not as simple as that. And then again, a colleague here, Professor Phil, whom again Ari will know, did a commentary for a magazine article where they were talking about plastics. And the point is, he made a comment that recycled plastic tend to contain more non-intentionally added and intentionally added substances than fresh plastics. And this has food safety implications. So somebody will say, why don't we just recycle plastic and use them? The challenge of doing that is once you are doing the recycling, you typically need to add a few other compounds so that the plastic will still behave like plastic. And those compounds may not be very good, to come into contact with food. So it leads us to ask the question, do all these waste to value initiative, do they encourage the creation of more waste? That's something we have to be careful about because we want to find out alternatives to use the byproduct. The fact that we are finding alternative, would that encourage people to actually generate more waste? Because they'll say, don't worry, the engineers will find a way to deal with the waste, which is a problem that we have to solve. So how do we avoid these secondary waste, from waste? One way I think we can look at it is, have like a circular economy system where we make something, we use it, reuse it, remake it, and recycle as much as possible. But like I said earlier on, at some fundamental level, waste is inevitable, but we need to limit and minimize it as much as possible to make sure that everything we are looking at, look at the environmental consequence, the health consequence, the economic impact, and also, again, sustainability. So if I put all that together, I started by talking about agriculture and how it's important for meeting SDGs. And then I made a case that agriculture alone cannot feed the world. You need food science, to process the food. And to achieve food security, sometimes the goals can be conflicting because you want the food to be safe, but that means you have to compromise on nutrition. But when it comes to the area of controlling food waste or getting value out of food waste, there are a lot of innovations that can be used. But it always starts with looking at the waste material to know what is in there. And once you know what is in there, you then think about a pipeline to use or a process to use to get that value out. It could mean you have to extract it out. It could mean you have to convert it into something else. It could mean you have to feed it to another organism like insects for the insects now to become a new product that can be used as feed for organisms. But there are always ways around most of these waste materials. But we have to do all of these things without generating a secondary waste. And that's really crucial. And one way to help us with this is the in silico prediction, where you almost look at what you can get out of the products through computer simulations before you go to the lab to do anything. So I'll end there, but recognize all the people who have helped in this research, colleagues, both during my PhD and postdoc time, as well as collaborators in New Zealand and my students, especially those who did much of this work, and other collaborators in different parts of the world. So I'll end here and give some time for questions. Yeah, thank you.
Thank you, Dr. So we have a request from Dr. Aji. Now it's time to open the floor for questions. For those of you here in the room, please feel free to raise your hand, and for our online audience joining via Zoom, you can also raise your hand if you would like to ask your question directly to the speaker, or you can type your question in the chat. Also, kindly introduce yourself by stating your name and affiliation before asking your question. For this, I would like to take questions from this room first. Student. It is very comprehensive lecture, Dominic and Solid. Any question? Any comments? Yes.
Terus. Yeah.
Okay, thank you to the moderator. Good morning, Professor.
Yeah, nice to hear from you. Thank you.
And nice to see you. Before that, let me introduce myself. My name is Muhammad Kamaro, and I'm from the Department of Agricultural Technology. And I wanna ask about the biodegradable plastic. Previously, I was interested when you discussed about the biodegradable plastic. Previously, I did research on biodegradable tissue made from particle fiber, and also biodegradable plastic made from HDPE waste, and WA sugar starch. According to you, can in the future the realization of biodegradable plastic from waste product be realized among the national children and specific in we and I to the children? Thank you.
Okay, now I caught some of your question, but let me try and answer the way I understood it. And if I didn't understand it, please repeat your question, okay? So yeah, so the last few slides, I made a comment about the research that was done by my colleague on biodegradable plastics and how they found out that even though the plastic is degradable, when it finds its way into water bodies, it was able to affect some fish in the body. Now that's basically the point that we're making. It's possible that this same plastic, if it's buried in the soil, it's not going to have any effect. Do you understand? So it's just a matter of the final destination of the product. That is what will determine whether maybe we need to be still concerned about what we call degradable. Maybe it's not as degradable as we want, or even if it's degradable, based on the medium in which it finds itself, there might still be some unintended consequences on living organisms. So I don't know if that was your question.
Okay. Can you explain in more detail in natural material can be used from biodegradable plastic and explain it for that?
Sorry, come again. So can I explain a bit more on what?
Okay. My question is that can you explain in more detail the natural material can be used from biodegradable plastic and before you explain before that? Because I'm so interested about the biodegradable material.
Yeah, I didn't catch the question very well, and I can hear you, but I couldn't hear it very clearly. Okay, now Ari.
Yeah. He asked about do you know other like maybe natural ingredients to integrate with the biodegradable plastic, so with less impact to the final destination, like you said.
Oh, okay. So natural ingredient that can improve the biodegradability of plastic. Is that a question?
Yeah, so that we do not create a secondary waste from that.
Ah, okay. I get you. Okay, so now before I actually attempt that question, let me make one point a bit clearer. Now, the study I mentioned is actually the first study I've seen where someone is raising a concern that biodegradable material could still have some unintended consequences in a water body. Okay, that's the first study. Now, that doesn't mean every effort at trying to investigate into biodegradability, we should forget about it because it doesn't work. No, that's really not the point. The point is that whenever we think about ways of using biomaterials, we have to be careful that we are not creating secondary waste, which can be a problem. Does that make sense? I hope you get that. Yeah. So just keep that in mind. So the whole enterprise of generating biodegradable material is good. We have to keep doing it. Yeah. Except that once you make a particular product, so from that study, I don't know, I think based on the way you're asking a question, I can see you've done a bit of work or read about biodegradation. You may be aware that for the most part, when people are testing biodegradability, all they do is bury the material in the soil and then keep checking the weight like every week or every 2 weeks and so on until the whole thing degrades, and then check the percent reduction. But that study is saying that maybe from now on, we shouldn't just look at how it degrades in the soil, but we have to look at what happens if the material finds itself in the water body. So that's really the point there. Okay. In terms of what compounds you can put in a food to make it more biodegradable, I wouldn't have the direct answer to that question, except to say that basically anything that is organic, found in organic material that can break down, we can expect it to also be degraded. So long as you're not creating a polymer that is too complex for organisms to metabolize. Okay. Yeah. No, I hope that helps.
I see. Maybe that's all. Thank you very much, Professor Teknik, for your issue.
No, that's okay. I think thank you too for your question. Thank you.
Yeah, and I think that's it. Thank you.
Thank you. Thank you.
Okay, I feel Zoom. There is three tunggal who wants to ask question directly. In Zoom. In Zoom. Yeah. Yes, Pak.
Okay. Okay, thank you. I will speak slowly to avoid mistake with me. My question is, how can we differentiate original plastic and recycled plastic when we buy food from the market? Maybe in our country, when we buy bakso, when we buy Taiwan, they use plastic. Thank you.
Now the answer to that will be a little bit different. What I mean is, okay, let me step back and say, in Australia, for example, whenever you buy anything, there's a label that says produce in Australia from 80% Australian ingredient and 20% imported ingredient. Okay. Now I know that's not the question you're asking specifically, but I mentioned that because in some part of the world, you have to distinguish clearly where the material is coming from. And I know in New Zealand as well, and I don't know if there are any other countries too, that you have to indicate whether the material is made from fresh plastic or recycled plastic. I've seen a lot of different, sometimes you go to a program and then they serve you like a takeaway pack, and the spoon and the fork, you will see that it will be written on it to say made from 100% recycled or 100% biodegradable plastic, or yeah. So I don't know whether that is a national policy that is required in Indonesia, but that will be the only way you know whether the material you are holding is from fresh plastic or from recycled one. I think it's only if it comes from a government. If it's made as a government requirement, then people will be bound by that law to state clearly where it's coming from. But also, there's a limit to what you can do with recycled material in food. For the most part, when plastic are being recycled, for the most part, they don't go back to being used in food products. It goes back to being used for other things, like just to maybe hold chemicals for, agricultural produce and things like that, rather than go into food again, because of the risk that it generates if you recycle and you need to add new chemicals to keep the polymer structure. Yeah. So yeah, so that would be my response. I think to know whether it's recycled or not, it has to be based on if the country has a regulation requiring people to state, you know, the level of recycling that the plastic has gone through. Yeah.
Okay, thank you. Maybe it will be our government homework, yeah. Okay,
Yeah.
thank you.
Yeah, that's true.
That's good. Yeah, thanks for your question.
Yeah.
Ibu Ari,
Ah,
boleh bertanya Ibu Ari dari Pak Ari.
okay, Pak.
Okay, thank you so much. A warm regard from Vietnam, Dr. Agi. Currently, I am guest professor here in Vietnam, and then here I am also teaching sustainable waste and wastewater management. I'm very happy to meet you in Otago. Yeah, and then I would like to give my insights related to your talk. Thank you for your talk. You discussed about the current status of development for agro residues-based value-added applications, and also the challenges and then future perspectives. And I'm in mind that agricultural waste will be a huge pool of biomass that may cause economical and environmental cues. But in the future, in developing countries such as Indonesia, for example, do you think that there are a lot of possibilities on developing more effective and efficient bioconversion technologies for converting agricultural leftovers, as you said, into high-value goods? And then my question is how to develop significant biorefinery concepts which aims to convert agricultural waste into a variety of valuable products within circular economy. I need your opinion in terms of these problems. Thank you so much, Dr. Agie.
Oh, yeah, thank you very much for the question. It's a very comprehensive question. I think that in developing country, like same where I come from, Ghana. Yeah, it's
from
yeah.
Accra. I was there. I was in Accra.
Ah, okay, that's cool. Yeah, that's our capital. Yeah, so okay. Now when I put up one of my slides with the percent waste for different produce, I'm sure you will know this, that in most developing countries, one of the stage of the food chain where a lot of food is lost is usually at the farm gate, because we don't have the post-harvest techniques that can prevent food from degrading, you know, too quickly. Let me put it differently. Here in New Zealand, typically the weather is cold. So it's like on average, if you have, let's say, a bit of vegetables like lettuce just lying on the table, it's not going to deteriorate as quickly as it would in Ghana, because in Ghana the climate is just hot. So because of just the normal, you know, tropical climate in most of these countries like Ghana and even in Indonesia, it means the risk that the food will go bad is very high. That means food waste is a big problem that needs to be tackled. So, but now follow on to your second question on what would be the best, you know, innovative strategies that can be used to produce more than one stream of product. I think the solution to that will always come down to the composition of the material. It all depends on what is in there. Once you know what is in there, you can then think about what's the best way to get everything out without leaving any waste material in, you know, as a final product. But the approach can differ, because in some contexts, it could be that I'm thinking of an example in my mind. Let me just make up an example. Let's say carrots, okay? Carrots can be used in some part of the way. You can get like juice it and get a bit of liquid out. It's a carrot juice or something. And then you have the chaff or the material that is left behind. Once you know, okay, the question is, what's the composition of this material? It's typically cellulose and a bit of carotene. Now that we know there's carotene in there, it means, okay, we can find a way to either extract the carotene out and use it for something, or we still mix everything back in together, maybe ferment it with some microorganism, and then we have a meal that can be used in baked goods. So that way you are not throwing anything away. So I think the simple answer to the question is we have to know what is in the material, and that will determine what kind of what we can use it for. And once we know what we can use it for, we can work back to see how do we get there and then find an appropriate stream. But I will still encourage processes like fermentation as really important in our part of the world where it's very easy to ferment things, because with fermentation, you break down most of the complex polymers like cellulose. You break a lot of these down into smaller, manageable molecules. You create a lot of flavor compounds, which add on to the sensory properties of the food. And if you use a probiotic, you're also making the whole material more healthy in a sense. So I think when a question like this is asked, maybe we shouldn't just look at sophisticated, complex, technologies, but maybe we should look into technologies that people can adopt, in the villages, let's say in the villages of Accra or somewhere, or maybe parts of Indonesia, which is simple, but can still be able to do the job. Yeah, so that would be my response to that question.
Yeah.
Yeah, thank you.
Thank you so much. Thank you so much. Yeah.
Yeah, that's
Regards
good.
from Vietnam to Otago and then to Palembang in Indralaya.
Thank you.
Thank you, Bu Ari.
Thank you, Pak Ari. Okay, I think because of the time, I will only take one question from student. If you not confident with English, maybe you can ask with English, bahasa Indonesia.
Iya, boleh. Moderator.
Yes. Now, our answer will give a question.
Good morning, Dr. Agi. Let me introduce myself first. My name is Walter Susono from the Agricultural Engineering Study Program. I'm very interested in regarding the reuse of the byproducts of agricultural products. My question is, I focus on this about how you mentioned there are some conflicting points regarding the recycling and the reuse of products such as plastic and several things. But my question is, it's still in line with the previous question, as what I think in developing country, how do you prioritize which agricultural byproduct that you actually need to prioritize in the valorization, as we have several aspects that we need to consider. As the first is the market demand, the nutritional value, and also the climate impact, or is it actually capable for us to actually tackle those three problems at the same time, or for the developing country, which actual problem for in regarding the valorization of an agricultural product that we actually should tackle and prioritize? That is my question, yes. Do you capture my question?
Yeah, I had a question, but yeah, I had your question. I had most of it. No, so let me put it back to you, and then you let me know whether that was the question. So you were asking, how do you prioritize in a valorization process? What goal do you prioritize? Were you asking whether you look at something that is more cost effective as opposed to something that produces like a bioactive compound out of it? Or is that a question?
Yes, especially in developing countries. I mean, there are several kinds of agricultural byproducts, such as, for example, straws and oats or something. For developing countries, which kind of agricultural byproducts do we actually need to prioritize?
Okay. Okay, I get you now. So among all the different byproducts, which ones should you prioritize and do some work on it? Ah, okay, okay. Now that's a really good question. I love it. So obviously, you see the question you're asking, it's not a question that has a right or wrong answer. It all depends on what you want. And my response would be, you prioritize the waste material that can give you, in New Zealand English, there's a phrase that says that can give you more bang for your buck, which means that can give you more value from the material. It could mean maybe, let's say maybe it's the straw, the example you mentioned, like straw. Okay, maybe from this straw, we can treat it in a particular way and get some compound out of it, and the rest will be fed to animals, and then animals become food, or the straw can be used to feed to insects. The insects can become feed, but we end up using everything without any leftover. One advantage of the using insects, some of you may know an insect called black soldier fly. It can eat almost anything. I think there are some studies that show another insect, mealworm, can even eat some plastic like styrofoam. So the advantage of such a process is that whatever you chuck into the bin with the insects, nothing comes out. They consume everything, which is a really good process, so long as you have an avenue for using the insects for something else. That strategy might be better than another one where, let's say, you are extracting something and then you are still left with, what do you do with the rest? And again, because you are extracting something, you may need solvent, you may need a bit of energy, you may need microwave and things like that, which makes the cost a bit expensive. Yeah. But if there's maybe a very unique plant in Indonesia, which contains a lot of, let's say, polyphenols, good for health, then sometimes there's a case to be made that maybe you have to go that route and extract those things out, because once you extract it out, because it's of a high value, the cost is very high, and it makes up for, if you're selling it, you can sell it at a high premium and makes up for all the cost involved in coming up with processes to extract it. So that would be my response there. Yeah. So just go for the one that will give you the most value. But that will depend on what you have.
Okay, thank you, Mr. Romney. I guess that's it for my question.
Yeah, that's okay. Thank you too. Thanks. That's a really good question. Thank you.
Thank you. Thank you very much. Because of the time, I have to close this session. Thank you all for your excellent question and for participating in today's discussion. I'd like to extend a special thank you to Dr. Alki for sharing your expertise with us and providing such insightful response. Before we conclude, let's quickly recap some of the key points we discussed today. I think the most important thing is to have a mindset that what we create will always create a waste. So if we want to be a responsible person, we have to compromise. And so if you have any further question or would like to continue the conversation, feel free to reach out to Dr. Agib or connect with us. Okay, with that, I'll hand it back over to MC to continue the event. Thank you again and have a wonderful day. And thank you very much, Dr. Agib. Have a wonderful day. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Dominic McGee and Mrs. Ari for the insightful session. The next agenda is the submission of certificate for our guest lecturer, Dr. Dominic McGee. The theme of agricultural faculty is within dismissal science. I guess the dean is absent, so I give the opportunity for the Vice Dean of Academic Agricultural Faculty to hand in the formality of the submission of certificate to our guest lecturer, Dr. Dominic to Mrs. to Professor Bill. The time and place is yours.
Untuk bersama dokumentasi.
Thank you so much towards Dr. Dominic and Professor Billy Satama. The next agenda is the documentation session. I kindly ask the public documentation committee to take over and for the professors and lecturers to go ahead in front to take documentation together with our guest lecturer today.
Sama sini. Iya, dua kali kan? Dua kali. Sekali di sini. Di sini bisa nggak? Di sini bisa nggak? Depan. Pak, di depan bisa nggak? Nggak bisa ya? Mana? Di depan.
Kelihatan nggak? Apa di belakang lebih?
Di sini Pak. Di samping Pak. Geser situ, agak biar layar. Iya, ya geser sini, geser lagi. Jadi kita masuk satu layar ini. Pak itu Pak ya? Wah, cek ini dia. Nah ini caranya. Tengah-tengah harusnya. Oh tengah-tengah. Oh tengah-tengah. Tengah-tengah dia ya. Nah, oh sini. Bisa gitu. Ada yang gitu. Itu yuk pas. Lucu ya.
Kita countdown. 3, 2, 1.
Sekali lagi.
Great smile. Okay. 3, 2, 1. Is there any kind of special pose?
Udah. Lagi.
Once again. 3, 2, 1. Okay.
Dari situ. Di zoom tidak? Di zoom. Di zoom juga enggak? Sudah di zoom. Udah tadi. Sudah tadi. Iya, di zoom. Sekarang.
Thank you so much. With that, we have come to the end of our international guest lecture on agricultural engineering 2024. Next semester ceremony. I extend my corporate gratitude to all, to the speaker, the participants, and organizers for making the event a success. Thank you for your attention, especially to our Dr. DKJ. Wassalamualaikum warahmatullahi wabarakatuh.
Sudah kok. Kita berfoto sudah. Sama-sama kita. Sudah kan sudah selesai kan tadi. Ya, terima kasih Pak. Silakan diploma. Silakan diploma.
Thank you so much, Dr. Aye. If you want to the room with this competition. Thank you so much.
Okay. Yeah, thanks again. Thanks for having me. Yeah, it's a really good experience for me. So thank you.
Thank you, Dominic.
Maybe there's a special way from the students for the way update. Hello from Indonesia.
Come here.
Thank you so much.
Yeah, thank you. Okay, now Ari, does it mean I can leave now?
Yes.
So that's it, right?
Yeah. Thank you very
Okay,
much.
thank you. Thank you.
Happy to have you.
Yeah, I'll be in touch.
Yeah. Thank you very much.
Yeah,
Have,
thanks. Bye.
have a nice midnight and evening.
Yeah,
No,
it's
no.
evening. Yeah, almost 5 p.m.
Yeah.
Okay, yeah, thanks. Bye.
Thank you.
Lanjut sesi dokumentasi gimana? Untuk sesi dokumentasi selanjutnya, dokumentasi satu lagi. Oh iya.
Moderator dapat juga.
Selanjutnya kita akan sertifikat dari koordinator program studi teknik pertanian ada beberapa pertanyaan. Foto dokumentasi pada dokumentasi nanti foto. Ini kan ini tuh ya kan. Terima kasih. Yang lainnya. Sama-sama kali. Sama-sama dengan mahasiswa. Ya, dosen dulu. Dosen dulu. Itu bagi dosen untuk pengalaman sehari. Ini dulu, itu dulu. Oh iya, ini. Ya. Lagi. Iya, Pak. Pak. Dokumentasi. Ayo, Ani.